Number 25. The water level varies from 12 inches at low tide to 52 inches at high tide. Low tide occurs at 9:15 a.m. and high tide occurs at 3:30 p.m. What is a cosine function that models the variation in inches above and below the water level as a function of time in hours since 9:15 a.m.? So ultimately they want us to write a cosine function. So that means I need two things. I need an amplitude and I need B, which I can find from the period. So let's take care of the amplitude first. It tells you that it is the water level is rising from 12 inches at low tide to 52 inches at high tide. Okay, so the amplitude is that distance between them. So we do 52 minus 12. So I get an amplitude is going to be half of that. So that's the total distance. Right, and our amplitude is kind of splitting it in half. It's the distance from the center line to your max and the center line to your minimum. So our amplitude is 20 inches. Let's put that here. Okay. Now that I have the amplitude, we need to decide if it should be positive or negative. Okay, so in this example, the water level is varying from low tide to high tide. So they describe it low tide up to high tide. Okay, so if we look at our graph, make sure your calculator's in radians, go to the graph. Now if we did positive, so like a positive 1 cosine theta, what does the graph look like? Right, at the starting point, that's starting at the peak. And if I made it negative cosine theta, it's going from low to high. So our amplitude is 20 inches, and our A is going to be negative 20. All right, so that our curve starts out at low tide to high tide. All right, now let's work on finding the period. So your period is 1 cycle. So the amount of time it takes from getting from, this point back to this point. And in this example, they gave it to us in measurements of time. So we have low tide is at 12 inches, high tide is at 52 inches. So it says that happens from 9:15 a.m. to 3:30 p.m. But hopefully you'll notice that that's just half a cycle. Okay, because we need a full cycle would be getting back to where it started. So whatever we get for this time, we need to multiply it by 2 to get a full cycle. So how much time is there from 9:15 a.m. to 3:30 p.m. if you count the hours? So 9:15, 10:15, 11:15, 12:15, 1:15, 2:15, 3:15. So we have 6 hours. And then I'm at 3:15. I need 15 more minutes to make it to 3:30. Okay, but we need it in the same units. I can't have hours and minutes here. So 15 minutes. We know there's 60 minutes in 1 hour. So if we do 15 divided by 60, we get 0.25. So half our cycle is 6.25 hours. And remember, we needed to double that to get a full cycle. So 6.25 times 2 is 12 and a half hours. Or let's put this as a fraction. hours, okay? So if we start building our equation, we have y equals negative 20 cosine. That was our amplitude, right? Cosine, and I can't just put in 25.5 hours. That's not b. Okay, how do I find b? Our period is equal to 2 pi over b. So our period is 25 over 2, and we're saying that's equal to 2 pi over b. So let's cross multiply. 2 times 2 pi. So b is 4 pi over 25. So our final equation is y equals negative 20 cosine 4 pi over 25 theta. All right, reviewing again, we made it negative, so it'll start out from low to high. 20 was our distance from the center to the peak and to the low point. And then 4 pi over 25, you use the times they give you to calculate the period, set that equal to 2 pi over b, solve for b. And that's how you do number 25.